So as discussed, guys, today the session would be related to the finders algorithm and the candidate elimination algorithm. So before we go ahead with the problem solving, so I just thought we'll have a recap on what we have learned already from the finders and candidate elimination algorithm, as this is a recap session. Okay, so what is finders algorithm? What do we do with finders algorithm? I want you to recall your concepts. What is finders algorithm? Or what do we do with finders algorithm? Few points at least. Guys, am I audible? Am I audible? I'll give a recap on it before we go ahead with the problem solving. So finders algorithm, basically it takes the hypothesis which have positive values. If you remember, finders algorithm only deals with positive values. We are moving from the specific to the generic hypothesis. We try to, if there is a specificity of it, we try to generalize it by giving, what do we assign the value? Either question mark, phi, or the actual value of the instance. In these three, which value will it take when we are going to generic part? It has each and every entity when I consider for the hypothesis, it has three values.
Question mark.
Exactly. So it is going to be a question mark. So either it will have a question mark, it will have a phi value, or it will have the actual value of it. The feature value of it is what we consider. So with these three options here in the finders algorithm, we will be moving from the specific to the generic part where we will be giving it as a question mark. When we identify there's a difference in it, we generalize it by giving a question mark. So this is how your algorithm looks, okay? Or the finders algorithm maximal specific hypothesis, okay? Finding a maximum specific hypothesis is what your find S algorithm is. Finders algorithm, it starts from the most specific hypothesis, whatever the hypothesis that we have, it takes the specific hypothesis among them and generalize it by considering only the positive examples. It only handles positive examples, okay? It ignores the negative examples as long as the hypothesis describes true target concept, because we already stated that when we are going to consider a hypothesis, we have to make sure that that lies within the concept learning. We are only going to consider the hypotheses that are most relevant to the concept, right? The target concept, and the training data contains no errors. Yes, it should not have any errors. Ignoring negative samples does not cause any problem, because in case if it has errors or considering the negative samples, you can avoid it to make sure that we converge to the correct solution. And it finds the most specific hypothesis with H that is consistent with the positive training samples. Yes, we are going ahead and dealing with only the positive training samples. So this is how your algorithm looks. So before that, we told that there is certain instances. If you remember this diagram when we explained it, we have, this is the instance space X. So to the left hand side of it, you have the instance space X. So which is telling I have four hypotheses, something like X1, X2, X3, and X4. Okay, these are my four hypotheses. So let me see what are those four hypotheses over here. I've defined my four hypotheses telling that I am today very interested to play tennis or not. This is what I have to get. This is my problem statement. Okay, based on the temperature, based on the conditions, okay, I'm going to decide whether I'm going to play or not. So in order to do so, I have to come up with the instances. So instances I'm going to give, tell that these are my instances which I've previously played or I would have given it prior. Okay, telling that, oh, it is sunny, it is warm, seems to be normal. So we know that the features of it, right? So the temperature, the humidity, the wind, the What were the other features, if you remember? Can you recall it? Air temperature, humidity, wind, the water to be cold or not. So we had those things, right? Let me just recall back. What were the instances that we had taken up? Yeah. So it was the sky, the air temperature, humidity, wind, water, and forecast. Okay, sky, air temperature, humidity, wind, water, and forecast. So the 6 parameters. For the 6 parameters, I have certain instances that I give, and the instances are here. Okay, so the instance seems to be first is sunny. So if the day, okay, the sky seems to be good for me to go ahead, sunny. The air temperature is warm, humidity is normal, wind is a bit strong, okay, and the water is warm, and same is basically the climate forecast if I consider. So if all of these things are better, if I really feel I would really like to go and play out today, okay, I will give a positive for that. The next instance also it is telling, okay, the climate, the sun, the sky is sunny, warm, high, okay, the humidity is bit high, the wind is also strong, the water is warm, and it is same. I really like to play out. And when it is too cold and rainy, obviously we will not have interest. So I'm going to give a negative sample to it. And again, if it is sunny, warm, high, and strong with cool, okay, if the water is also cool, I'm going to take it as positive. So these are my 4 instances that I'm going to consider. When I have these instances with me, from these instances, how am I going to come up with a generic one? Okay, or how am I going to have a more specific one by generalizing the content? So here in this diagram, we see that, see, the topmost is actually the specific. In the sense, I just have H0, okay, is going to be the specific, which is all 5. Okay, 6 parameters I have, that is 6 features I have. So all the 6 features has been initialized as a first step of findness algorithm. It is all initialized to 5. So I have everything initialized to 5. And the second one, you can see H1, okay, it is below that, which means there are certain terms. It's not specific completely. There are something which is below that. Then what I do, as I go ahead generalizing it, I can see that I'm moving from the specific part to the generic part. How do I actually move from specific to generic? Let's see this example. We'll take a new example as well. So let's just go ahead with this first example. I want to correlate with the diagram and make you understand what exactly we are doing. Okay, so H0, I already stated, we are initializing it to all 5. It is most specific hypothesis. Okay, I'm assigning H1 with respect to X1. Okay, assign the first instance, which is a positive instance, because I'm going to only deal with the positive instances here. I'm going to take the positive one, which is the X1, where I'm assigning it to H1. H1 is all the values that I give over here. So you can see sunny, warm, normal, strong, warm, and same. The same hypothesis, the instance I'm going to consider as H1. Okay. Now what I do, I will compare H1 with respect to the next input instance that I've got called as X2. Okay. So I'm going to compare H1, okay, with the next upcoming positive instance, which is X2. Okay, so in that what I do, so I will come up with a new hypothesis now. So representing is a H2. H2 is equal to, because I have to compare each and every feature along with that. So sunny is going to be compared with sunny. It seems to be same. There is no change observed. So I'll replace the same quantity here. So it is going to be sunny. The feature sunny remains same. The next one is warm. Warm and warm. Again, when I take the values of it, there's no change observed. So I will keep the same warm feature over here. The third feature, if you consider, which is the normal and the high, there is a change that is observed. When there is a change observed, I have to move from the specific term to the generic term. So when I tell I'm generalizing it, I have to replace it with a question mark. Okay, so you can see here, I've replaced the third term because there was a change in the attribute value. So I've replaced it with question mark. Okay. And then the fourth term, strong, is again strong. So it remains the same. Warm, warm, same and same. So the remaining does not change. So we have all the others same. Now next, again, I have to compare H2, okay, with the negative. Should I compare it with the negative instance, the upcoming X3?
No, ma'am.
Because we only deal with the positive instances. So I'm going to eliminate X3. Okay, I'm not going to compare it. So H3, I'm just going to consider now. So I'm going to write it the same value after H3. Okay. So H2 becomes H3. I'm replacing the same because I have a negative instance over there. So from here, I'm going to compare H3 with the next positive instance, which is X4. Okay, the next positive instance immediately after X3 is X4. So I'm going to consider H3 is compared now with X4. Okay, now let's have the same comparison. The first term sunny is the same as sunny. The warm is same as warm. See, I already have a question mark over here and there is a change in value. Since it's already generalized, we need not be concerned more about it. So it remains the same. Okay, so the value remains the same. The next term is strong, and again here it is strong, which means it's same. There is one more term that is getting changed with warm and cool. Warm and cool, both are different. Okay, we have to generalize it now. So when I'm going to generalize it, I'm going to replace it with a question mark. Okay, then I take the last term. The last term, it is telling it is same, but here it is actually a change. Okay, again, there is a difference in the attribute values. So I replace it with a question mark. So finally, I have H4. I will consider if there is any other samples over here. Since I had only 4 samples, I need not consider the 5th sample here because I don't have any samples that I have to consider. So H4 will actually become my most specific hypothesis for this given problem statement. Okay, so if we look at the diagram, right, you can see H4 is over here. For the given instances, H4 is the one which we are considering, okay, with all the generic terms in picture. So from H4, if I scroll up and see, so H4 is last, then you see H2 and H3 is same here. H2 and H3, because it was a negative instance, I did not perform any of the actions for that. I just considered H2 is equal to H3. I replace the values same. Okay, so H2 and H3 is lying over here, and above that is H1, above that is H0. So we are trying to move from the specific to generic, the movement of it. With an example over here, we slightly came down to what we wanted, the hypothesis that was required with respect to the FIND-IS algorithm, the maximally specific hypothesis we got through by considering the most specific hypothesis and generalizing it. Do you have any queries here? Do you have any queries, guys? Any queries? No queries? So you're clear about the concept. Okay, so if we look at the algorithm, because every time we consider an example and through the example we come and write the algorithm. So let's see what the algorithm states. So the algorithm is you're going to initialize. I'm going to initialize the hypothesis, that is H, to the most specific hypothesis. Most specific hypothesis is all 5. Okay, so I have initialized that. Yes, step 1 is done. For each positive training instance, yes, I only consider the positive training instance, yeah, X. For each attribute constraint AI in H. For each attribute constraint, the sunny value, the warm value, the normal. So they are the each constraints, okay, of AI in H. If the constraint AI is satisfied by X, do not nothing. Do not do nothing, because if the value of H and if the value of AI, that is both the values, they are actually matching with. AI is, so H hypothesis is basically it is telling A1, A2, A3, so on up to A6 we have. Okay, and the similar, the X was our input instances. Okay, from the input instances again we have the 6 attribute values. So AI is compared with the value in X. Again, A2 is compared with the next value in X, A3. So each and every comparison is going to happen. That is why it is telling if the constraint AI, the value of whatever I get it from here, AI is satisfied by X. If it is satisfied by X, do not do nothing. If I have the same value, I did not do anything. If not, I replace AI. So I'm going to replace the value in this in H by the next more generic constraint. So I used to replace it with a generic constraint with a question mark. And I finally gave up my output hypothesis. Each and every time I compared, if I find a difference, I place a question mark. Again, I take the next positive instance. If there's a difference, I'll see it. Then again, I replace the question mark. So finally, I came up with all the input instances and the particular hypothesis. I got my value, the output hypothesis H. So this is what our algorithm is with respect to find S. So let's consider a very practical example now. I don't want to take the examples that we have in our book right now. Okay. So the example will be like, okay, let me just write it over here. I'm going to give you an instance, x1, x2, x3, x4, x5, 5 instances. So I'm going to take, let's consider a very practical example. So the attribute values, okay, you have to tell me. The subject you like, okay, SL, the subject you like. The subject you don't like, okay. What are the other parameters that we can give? Think over and let me know.
I'm a scoring subject, ma'am.
Okay, scoring subject. SS, scoring subject. Yes, next. Subject you like, subject you don't like, subject is a scoring subject. Any others that you can guess? We'll create something new rather than having our old examples all time. Because this is completely related to you, so you have to let me know now. 2 more. 2 more is enough. Okay, let's consider the name of a student or USN of a student. Okay, USN. And we need one more. Let me take another color itself. One more. USN.
Ma'am, the semester the subject belongs to.
Ah, yeah, right. The SEM. Okay, I have 5 now. Give me the instances now. X1. One student should tell me which is the subject they do like, which is the subject they do not like, the subject that they can score well. Tell me now. Yes, Shamishta, let's consider your example itself that you like, you don't like. Come on, tell me, subject you like.
Ma'am, algorithms, ma'am.
Okay. Algo, fine. Subject you don't like.
DBMS.
Okay. Guys, this is for fun, okay? This example we're gonna, just for our understanding, and it is for fun. No offense here, okay? Fine. And subject you feel that you can score much.
I'm DBMS.
DBMS, you don't like and you can score well in that, okay? DBMS, fine. Okay, USN?
97, ma'am.
Okay, 97. Yes, semester.
5th, ma'am.
Okay, 5th semester. Okay, we have our first instance. Second instance. Who's gonna ready to tell the second instance? Come on, guys. Should I point out you? No? Come forward. It's all open for you now. Second instance. Should I point out? Sujo? He's not there? Varna?
Yes, ma'am.
Yes, Varna. Tell me now.
Ma'am, subject I like Java.
Okay, very nice. Java. Okay, next.
Which I don't like is HCI, ma'am.
Guys, again, I'm telling no offense here, okay? It's just an example, okay? Subject you like to score.
Scoring subject. BBMS, ma'am.
PBMS, okay, fine. Yeah, USN,
126.
okay. Semester,
7 sim.
okay. Fine. Third instance. Who wants to come up? Come on, be proactive, you know. We're trying to learn something. So be proactive, guys. Someone next? Vaishnavi?
Yes, ma'am.
Hmm.
Ma'am, the subject I like is ADA.
Okay. ADA.
I don't like computer networks.
Okay.
Scoring, I think I can maybe data structures, DS.
Okay.
USN 124
Hmm.
and 6th semester.
Okay. Next instance. Who's ready next? Come on, guys. It means it's really so odd to call out you. You have to tell me. 60 people in class. Come on. Next. Nitya, you're there?
Favorite subject is ADA.
Okay.
The subject I don't like is microprocessor,
Okay,
and
Muki.
then scoring subject is DBMS.
Okay.
Um, and yeah, USN is 134, ma'am.
Okay. Semester?
Oh, semester. Ma'am, like, should I tell the semester of the subject or the current semester?
You're thinking out of the box. Give me one number.
Oh, okay, fine. Fifth sem.
Okay. Yes, the next instance, guys. Shivitsa?
Yes, ma'am, I'm here.
Hey, come on, guys. You should not be like this, you know. Like you have to come proactively tell, ma'am, this is what I want to tell. You know, that's the way it has to be. Because we're just creating. This is just an example problem that we're considering, right?
What SL, ma'am?
Sorry.
SL. SL. I'm not.
SL. Ah, yeah. Subject you like.
Okay. That will be Linux.
Sorry.
Linux.
Linux. Okay. Oh, you're a good Linux programmer then. Okay, next.
Subject I don't like is Java.
Oh. Okay.
And scoring subject is cloud.
Okay. 108, if I remember.
Yes, ma'am, 108.
Semester?
7.
Okay. Now you start. This is your given data. I want you to come up with more specific hypothesis with your find this algorithm. Try to compare and tell me what you'll get. I know the answer now itself, but you have to tell me the answer. Can you solve this problem, guys? Have your paper and pen with you? The X1 instance is algorithms, DBMS, 97 and 5. X2 is Java, HCI, DBMS 126 and 7. X3 is ADA, CN, data structures 124 and 6. X4 is ADA, MUPI, DBMS 134 and 5. X5 is Linux, Java, Cloud 108, 7. What is your step 1 now that you have to do it with the find this algorithm? Step 1.
More specific hypothesis.
Yes, which
And
is the
then-
more specific hypothesis. H0, what are you going to initialize it to?
5.
Okay, so all 5. So H0 is equal to all 5s because we have 5 features over here. So all 5s, yes. Now, the next is H1 is going to be assigned to?
X1.
Yes. Comparison of X1 with?
X2.
Yes. Oh yeah, we forgot to give whether it is a positive or a negative.
Yes, ma'am.
So I'll take all positive because I want my students to be all positive, no negatives here. So I have a unique data set which is having all positives. Go ahead now. So you have to tell me what is H1, H2, H3, and H4. Sorry guys, I'm writing it over here to the end of the screen because I don't want this data set to go away now if I erase it or move to the whiteboard. So H1 is going to be compared with X2. So what will be the value of H1 now? Still doing?
Only scoring subject will be DBMS. Rest all will be question marks.
Yeah.
Yes, ma'am.
Why is it question mark?
Ma'am, because it doesn't match, ma'am.
Yes. So I have DBMS and the other things are question mark. Okay. Next, I have to assign. I have to compare H2 with. Comparing H2 with. What am I comparing H2 with next?
X3.
X3, yes. What would I get there?
Everything becomes question mark because even the scoring subjects is different.
Exactly. So I will get everything as a question mark here. That is basically one of the disadvantages with find this algorithm. That's the reason I wanted you to give your answers for. Okay. So now what we'll do is I'm going to change this table, existing table itself slightly with the numbers. Okay. So I am just going to erase the USNs. And I'm going to change few of the subjects. Okay, so okay, so Java, I will have DBMS here as well. Oh, sorry, I'm not writing it properly. Okay, this is DBMS. DBMS. Okay, and here it is going to be Java again. Okay, and So by looking at the table itself, you have to get to know what you will get your answer for the finders. I have to take another color for that. Okay. So I'll give CN itself here. Anyways, again, I'll get a question mark for that. Okay, so now you just guess it out here. What should you get? So the value of this is USN number. I'm just going to give zeros, which means any student. Come on. Now you give me the answer for this. So your H1, H2, everything will change. We want the hypothesis to be read out again. Guys? Is it okay here? So the X1 is Java, DBMS, DBMS 0 and 5. X2 is Java, DBMS, DBMS 0 and 5. X3 is Java, CN, DBMS 0 and 6. X4 is Java, CN, DBMS 0 and 5. X5 is Linux, Java, DBMS 0 and 7. What is the initial step? H0 is all 5 for all the 5 features. H1 is going to be compared with, H1 is assigned to X1. So H1 will be compared with X2. What will be my comparison be? For what is my H1 now?
H1 is the X1 values itself, right? Java, DBMS, DBMS, 0, 5.
H2?
Everything remains except the semester. Semester will become a question mark. Because
So
it's
going
Java,
to be
Java.
Java, DBMS. Again, it's going to be DBMS. Any student, and it's going to be a question mark because I have a change in the value from 5 and 7 observed here. So I'll get the first one. Okay. What is H3? H2 is next going to be compared with X3. So H3 is?
Java, question mark. I think DBMS remains. 0 and question mark.
Yes. Okay. Now H4.
Java remains. Question mark. DBMS 0 question mark. Same thing.
Yeah. Finally, my H5. I'm writing it top here. Little big. H5.
Question mark.
Question mark.
Question mark.
Question mark.
DBMS.
Yes, DB.
0 question mark.
0 and question mark.
Question mark.
Yes. So from the example, previously we saw that when we have different instances, the values of the instances, when we are trying to make it to generic, we get everything as question marks. Okay. So to overcome that, like I just changed the given problem statement itself, keeping few terms common, like this term. You can see here entirely the DBMS here, this column is completely there. And again, you can see the 0 that is just common for all the student. So you can easily predict your answer, what it would be, because everything is common over here. Obviously, I will surely have these two columns with the value, and the remaining will change as question mark. But you have to perform each and every step and show, because there's a value for it. You just write the answer for it, that's not sufficient. You have to write the procedure, how you came to that answer. So assigning it, you have to neatly write H1 is assigned with X1. H1 is compared with X2. Comparison, give that. Again, H2 is compared with X3. Give the answer. H3 is compared with X4. Give the answer. H4 is compared with X5. Give the answer. The final hypothesis is H5. And this is what we will be telling. It is the most specific hypothesis for the given problem statement. The question is very easy. Find a algorithm is very easy. But the only thing why we need that procedure or steps is because how your understanding is with respect to the given problem is going to be tested. So make sure even you get a question mark for all of the values, yes, but we have to get to know how did we come up with that question mark. That means that gives actually the major importance for the question. Okay, so now are you clear with the finders algorithm? Do you have any doubts with finders?
No, ma'am.
No, ma'am. No
Done.
doubts.
So the numerical of finders is ready. So any problem given to you, you'll be able to solve it, right?
Yes, ma'am.
Okay, cool. So I'll clear the screen. We'll go ahead with